In this lecture, we will talk about the partial fraction decomposition. Let's look at this example. This example says that we have a rational expression 11x minus 6 divided by x minus 6 times x plus 4. How to find out the decomposition? You see right here we have a 11x minus 6 for numerator. Denominator is a quadratic one, means degree is 2. When you FOIL it out, you know that. So we want to find out previously what was those two fractions add together and get this one. Okay, and here the first one, x minus 6, is from this one, and x plus 4 is from here. And remember, we don't know a and b. That's what we need to find out. And here a and b are constants. So if we don't know, we assume they are a and b. And then let's add those two together to see what we get. We know in order to add x minus 6 and x plus 4 together, x plus minus 6 needs to have x plus 4 and x plus 4, and x plus 4 needs to have x minus 6 for denominator and also x minus 6 for numerator, because you know x minus 6 divided by x minus 6, you can cancel it, you get 1. So 1 times b of x plus 4, you have a b of x plus 4. Here it's the same. Okay, the reason is the same. You put x plus 4 for numerator and x plus 4 for denominator. Then you have a common denominator, x minus 6, x plus 4 on the left, this one, and x plus 4 times x plus 6, the second fraction. Once you get denominators are the same, you can leave it. You do numerators. A times quantity x plus 4 is x times a times x, a times 4. So you get 4a here. This quantity a has to multiply both two terms inside. Okay, so a times x and 4 times a. Similarly, for b times x minus 6, b has to multiply x, and b has to multiply negative 6. So you have 6b negative from here. Okay, and b times x. So you get that. Now we are ready to put those two together because denominators are the same, so we just write one denominator. And the upstairs on numerators, we combine like terms. ax plus bx, we pull x out, that's a plus b. And then 4a goes with negative 6b. Okay. So those two, this one will end up with a constant, and a plus b will end up with a constant. And x minus 6, x plus 4, here are the same with the one right here. In order to let those two be equal, denominators are the same again. A plus b has to be 11. Okay. 4a minus 6 has to be negative 6, because this whole thing has to be negative 6. 4a minus b, whole thing right here, has to be negative 6. Okay. Coefficient of x, a plus b has to be 11. Then we got two equations. Okay? All right. Now our job is to solve this linear equation system. Then we can apply previous knowledge. We know A is that in front of A there is a 1. In front of B there is another 1, because 1 times A is A, 1 times B is still B. So we know the coefficient of A and B, they are 1s. And then we take the constant 11 back here, 4 back to here, negative 6 here, negative 6 here. This is augmented matrix. Okay, now let's eliminate this 4. So upstairs needs to multiply by a negative 4. So you see 1 times negative 4 is negative 4, 1 times negative 4 is negative 4, 11 times negative 4 is negative 44. So we are ready to add this red number onto the second one to cancel this 4. Negative 4, positive 4, you get 0. Negative 4, negative 6, you get negative 10. Negative 44 with negative 6, you have negative 50. And the first row, 1, 1, 11, we copy it down here because we didn't do anything with that. Okay, so this operation basically is row 1 times negative 4, we get red number, and add onto row 2, we have a new row 2 here. So we like this place, negative 10, this place, be positive 1. Okay, so we divide row 2 by negative 10. 0 divided by negative 10 is 0. Negative 10 divided by negative 10 is 1. Negative 50 divided by negative 10 is 5, positive. Row 1, again, we leave it. 1, 1, 11. We didn't do anything. Okay, now we are ready to eliminate this place. Make this place be 0. So we need negative 1 in this spot. Because negative 1 add here, this place will be 0 then. Okay, so row 2 needs to multiply by negative 1. 0 multiplied by negative 1 is 0. 1 multiplied by negative 1 is negative 1. 5 multiplied by negative 5, multiplied by negative 1 is negative 5. And then we are ready to add this red number to the first row. 0 plus 1 is 1. 0 plus 1. Negative 1, the red number, add on positive 1, so you have a 0. Negative 5, add to it 11, positive, so we have a 6. This operation is negative 1 times row 2, we get red number, and add onto row 1, we got new row 1, which is 106. Again, red, 0 plus 1, 1. Red 1, negative, plus black 1, 0, negative 5, red 1, and black 11 together is 6, positive. Okay, now, second row we copy it. And then you write this one back. Okay, so 1 times A is just A. 0 times B is just 0. And 6 is this one. So actually A equals 6. Because 0 times B is 0. So A is actually 6. Okay. And 0 times A is 0. You may write 0A. You may write 0. Okay. And 1 times B is B. And 5 you put here. So it's actually what? B equals 5 right here. Okay. So we have a value for A, which is 6. That's here. And B is 5. That's here. Okay, so 6 for A, and B is 5. And then we know, this rational expression is the sum of those two rational fractions. So that's the partial fraction decomposition. The reason we are doing so is that in calculus, when you are going to find out the integral of this one, you need to find out the integral of this one and the integral of this one. Okay? So this one needs to be decomposed as the sum of these two fractions. That's why this class is called pre-calculus, and we'll use this in calculus. So we will not use here in pre-calculus. Okay. Again, for this example, you got to assume we have a b and then find out, okay, by solving the system of linear equations.